Okay, so again, they're asking us to find out where these points intersect. Technically, I need to find out if these are parallel lines. Okay, so from the parametric form, I'm going to quickly draw the direction vector out of it. The direction vector, if you guys take a look, we're going to have the numbers 1, 4, and 5. That'll be a direction vector for line 1. So 1, 4, 5. And our direction vector for line 2 is -1, 2, and -5. -1, 2, -5. Quickly, 1 to get to -1 would be multiplied by -1. And if we multiply -1 by 4, that does not equal 2. So boom, not parallel lines. Okay, one's not a scalar multiple of the other. So we've disproven cases 2 and 3. Now we'll get into case 1 and 4. Because it's already in parametric form, it makes it a bit easier for us. We're going to set the two equal to each other right off the bat. So, I'll set my x value. Our new equation 1 will be 1 plus s is equal to 4 minus t. 3 plus 4s is equal to 17 plus 2t. And that's equation 2. And equation 3 now says 6 plus 5s equals 30 minus 5t. Just like in the other one, we're going to set 1 equal. The first equation looks relatively simple. S is equal to 3 minus t. Great. I take that s value, I'm going to plug it into equation 2. 3 plus 4 times 3 minus t is equal to 17 plus 2t. 3 plus 12 minus 4t equals 17 plus 2t. We'll get the variables on one side. 2t plus 4t. And 3 plus 12 is 15 minus 17. Negative 2, 8t. Negative a quarter for t. Okay. Are we good? Oh, sorry, 6t. Thank you. 1/3. Thank goodness we have people who actually know math. Okay, then we're going to take that t back into equation 1 because it's relatively simple. S is equal to, we'll put this to a fraction of 3, 9 over 3 minus negative 1/3. So we'll be adding the two together. We're going to end up with 10 over 3 for our value of s. Now, in the other one, we took these two values, if you recall. We took our parameter of t and we took a parameter of s, and we plugged them into the third equation. Oh, it's supposed to be -1 plus s? Uh-oh, that's going to change everything. Did I write it down wrong when I wrote it in? Oh, that's supposed to be a negative? That's okay. Let's just go with what we got anyways. I'm getting the feeling these will be skewed lines anyways. So, we took them and we put them back into equation 3. Now, if equation 3 doesn't end up being equal, this is a fast way of proving that these are going to be skew lines, okay? Because our s and t didn't work, that means our third equation doesn't work. But we want to really prove it. We want to see what the 2 points they represent are. So we're going to take s and t, the two values we got now, and we're going to put them into our parametric form over here, line 1 and line 2. And we're going to see if they end up with different values for x, y, and z. Okay? So just like before, I'm going to copy and paste. It's easier for me. There we go. So here's our parametric form. We're going to plug those values in. So for line 1, x is equal to, we're going to keep it original where it's just like we said before, 1 plus 10 over 3, which is going to give us 13 over 3, okay, as a fraction for x. Y gives us 3 plus 40 over 3. All I do is multiply 4 by 10 over 3, which is going to give us 43 over 3. And z is equal to 6 plus 50 over 3, which is giving me 68 over 3. Okay. So those are what we got for our line 1. Those are the points of intersection according to this. Line 2 points of intersection. What was our t-value? Negative a third, right? Okay, so x is equal to 4 minus negative a third, which is the same as adding it. That would be 12. Shoot, does that give us 13? Yep. Uh-oh. I wanted skewed lines. Hopefully this works. Y equals 17 plus 2. Our t-value again was a third. So that's going to give us negative 2 over 3. Negative 2 over 3. 17 times 3, what's that give us? 31 over 3. Is that right? 51 over 3. Yes. 51 over 3. Minus 2. Yes, here we go. 49 over 3. And we'll do the z just to make for consistency's sake. Our z value was... Hey, where is our z value? Oh, there it is. 30 minus 5 times negative a third gives us, this will be 90 over 3 plus 5 over 3. It's going to give us 95 over 3. Okay. So if you notice, the first point ended up being the same, but our points from there on were not the same. So because those points are no longer equal, or not equal, sorry, I should say, they are skewed lines. And we could have proven this, just like Sharif had asked before. If we plug this into equation 3 would not have worked. And if equation 3 wouldn't have worked, technically we don't have intersecting lines. Okay? So we know they weren't parallel. We knew they weren't coincident. We got rid of those. And because equation 3 didn't work, we then know we don't have intersecting lines. Right away, only other option left is skew lines. Okay?